If you look through a glass prism, such as for instance these, the world becomes lively colored, overwhelmingly complex, at least as it seems. But what you see when looking towards the bars of a window against the bright sky is even more remarkable. Namely, it seems that color only appears at the borders where bright and dark areas meet. Maybe there are some laws governing the prismatic color phenomena after all. To look closer into this, let us study simple pictures in black and white as, for instance, this checkerboard pattern. Here the prism is held horizontally and the pattern rotated. There is a simple law behind the seeming complexity of the first impression. Look at a sharp border between dark and light. The prism is held horizontally. As soon as you rotate the pattern, colors appear, alternatively blue colors and yellow colors. These are the so-called boundary spectra, a transition from white via yellow, orange and red to black, alternatively from black via blue, violet and turquoise to white. See what happens when we let the two kinds of boundary spectra partly overlap. Here red meets dark blue, and the result is a spectrum with purple between yellow and turquoise. Changing over to the opposite condition, let yellow and turquoise meet, resulting in a spectrum with green in the middle, between red and dark blue. Thus, there are essentially four basic prismatic spectra. The first two are the complementary boundary spectra, the yellow one and the blue one. Further, when the two elementary spectra are forced to overlap, you get new spectra containing shades of green and purple. To the right, the well-known Newtonian spectrum with red, green and blue-violet. To the left, the inverted spectrum with yellow, purple and turquoise. The two spectra are complementary, in the sense that if they are superimposed, that is, if they are produced in such a way that they appear at the same place, the result will be either just white or just black, depending on the way of combination. These four kinds of spectra represent all possible chromaticities attainable by spectral modification of light. The demonstration shows the importance of both light and darkness. Color is based on contrast. It is not fair to say that colors are in light. They are, in a sense, created between light and darkness. The famous physicist Isaac Newton, in his time, proposed that the spectrum, produced from a narrow beam of light in darkness, displays side by side the elementary components of sunlight, so that you can separate out rays of monochromatic light, for instance, a green ray from the middle of the spectrum. Due to the light-dark symmetry principle just demonstrated, it should as well be possible to separate out monochromatic rays of shadow from the inverted spectrum. For instance, a purple ray, as shown here. How this is done is another story, however. You can get to learn more about it in another video.